I'm Colin Archibald. When you come to Valencia to study computing, there's a number of different degrees you can take. So let's have an overview of what all the possibilities are. When you come to Valencia, you can do one of two degrees, an AA or an AS. So an AS is an Associate of Science, and an AA is an Associate of Arts. Within the AS, you can choose your degree. You can take an AS in Computer Information Technology. So let's call that one CIT, ASCIT. Or you might take an AS degree in Computer Programming and Analysis. Let's call that one CP&A. When you do an AA degree, you can choose a transfer plan or a pre-major. A transfer plan is choosing your courses in your AA that will best suit the bachelor's degree that you'll eventually take. So you could do a transfer plan in information technology, a transfer plan in computer science, or you could do a pre-major in computer science, or a pre-major in information technology. So these are the most common paths, the most common ways you would take a degree in computing IT at Valencia. Where do these get you next is the important part. If you do an AS degree, you're either going to go to work with that degree after 2 years, 60 credits, or you're going to do a Bachelor of Applied Science. So you could go to UCF and do a Bachelor of Applied Science in software development or a Bachelor of Applied Science in information technology. So I'm going to call those SD and IT. You cannot get into the Bachelor of Applied Science unless you have an AS degree. If you take an AA degree, you're going to do a BS, a Bachelor of Science degree. This is the most common path. You could do a Bachelor of Science in Computer Science, you could do a Bachelor of Science in IT, and those pre-majors are specifically designed for UCF. So the classes that make up the 60 credits in the articulated pre-major are specific to going and doing these degrees at UCF. You don't have to go to UCF, and you could do a transfer plan and go to any other university in Florida as a third-year student to do a Bachelor of Science in, most commonly, computer science or information technology, although some colleges, some universities have other bachelor's degrees that might be interesting. Okay, I put them in this order so that you can try and figure out which one is most appropriate for you. This one has the lowest math requirement. The AS in CIT means that you're going to be a techie, the IT techie in a company. And the math requirement there is any math course that meets general education requirements. So it's the lowest possible math requirement. The math requirement in the pre-major in computer science is 2 layers of calculus and 2 layers of physics with calculus. So this is the highest possible math content, and this is the lowest. It also goes from the most applied to the most theoretical. If you're going to be a software developer, AS in computer programming to applied science in software development. If you're going to be a computer scientist, an AA pre-major in computer science, and a Bachelor of Science in computer science. We also could say that out here there are master's degrees and doctoral degrees, which aren't as common here. So in the applied, you're expected to go to work here, and in the more theoretical, you are prepared for going to graduate studies. So that's kind of a summary, a very high-level summary, and I'm not telling you which one of these is better. They're all good. It's up to you to decide which one is right for you.
Hello, I'm Ian O'Toole. I manage the labs here, the IT labs at West Campus. And we do a couple of things around here. For one, we keep the hardware and the software working that the faculty and the students use for their classes. And then the other component of what we do is we provide tutoring services for our students. And that includes our on-site students as well as our online students. So we have an open lab here at West Campus, and tutors who are here for a lot of hours each day, and they spend that time tutoring students, helping them with assignments, helping them understand concepts that they have trouble with. And then for our online students, we also have an email address, Skype accounts, Google Hangout accounts that we use to communicate with them and help them work on their homework and help them get over any trouble spots that they encounter. So one of the benefits that the students in our program get here at Valencia IT is they get access to the DreamSpark Premium program, which allows our students and our faculty to download and install all sorts of Microsoft products, from Microsoft Access to Project to Visio to Windows operating systems. So that includes Windows 7, 8, and even 10. The students are able to get Visual Studio and other programming development environments that they can use here in the lab and on their computers at home. One group of software that's not included with DreamSpark is the Office Suite. However, all Valencia students have access to that software through the Office of Information Technology. They can download and install that software at home and use it here on campus as well. We also have all sorts of other software here in the labs that our students use, including Adobe Dreamweaver and other proprietary software that does not get sent home with the students, but they can use here in the labs. This is our open lab in Building 7, room 120C, and this is where the students can come in and work on their assignments and get help from our tutors if they're stuck with anything. And we don't work on appointments here, so you can walk in anytime during hours, and you can check the web for our hours and come in anytime and get help with your assignments.
Well, this setup here is this is a rover, a vehicle, programmable. It navigates autonomously. In other words, it'll be able to drive itself. It's a project that my students in the Selected Topics class, Physical Computing, worked on in this last term, and we're actually still working on it. It has a Raspberry Pi on it that has software in it, that program that the students and I wrote to control the speed of the wheels. It has 2 Arduinos on it that actually measure the position and movement of the vehicle, so we can figure out where we are and which way to turn. And it has a lot of software on it in terms of programming. And we're working on the grand plan of this will be that we'll be able to put this down in a location and have it drive to another pre-programmed location. So it's a very good example of an embedded program, of how software talks to hardware. In this case, there's a program embedded in the Raspberry Pi that drives to wheels, and there's programming written in C that is in the Arduinos that does the navigation. So you actually have 2 different languages, 2 different processors on the same robot, and it makes a very good way to learn about programming. This is a project that students constructed in the physical computing class. That's COP 2930. That's a selected topics class that's offered periodically by the college. And programming students take that to learn about programming actual hardware devices. This is our ball shooter. And when I turn it on in just a minute, these wheels are going to start spinning. And we have an Arduino that controls the speed of the wheels and controls the timing. And after the wheels get up to speed, the servo is going to open a gate. Balls are going to roll down the ramp, and they're going to go shooting off. If you vary the speed of the motors from one side versus the other, you can make the balls curve or go on a different trajectory. That's what we were experimenting with in class. So I'll turn it on, and we'll see how it works. Hopefully it will work. There we go. There should be a dramatic action here in just a moment. There you go. This is a really simple robot made out of spare parts that I put together to use in the C programming class, where we're looking at learning about programming in C. And this is an Arduino, so it's programmed in the C language. And this robot has a display, so you can display messages. It has 2 motors and has a sensor that counts how many times the wheel turns. And from that, you can figure out how far the vehicle went, which is what we were doing in the C class. We were just taking the data off the wheel and figuring out how many times it turned, times the diameter, circumference of the wheel, gives you the distance. If I turn it on, it should run around a little bit on the floor here. It doesn't run too well on carpet, so this may not be spectacular, but you should be able to see basically what it does. If I can get it plugged in here. Looks like we're backing up. And we don't really have enough room here to do the full thing, but it needs a pretty big, because it turns really wide, it needs a pretty big space to turn successfully. This is our brand new 3D printer. We just got this installed yesterday, and it allows you to create a design in the computer using software, 3D design software, and then it allows you to actually print these, your design out in plastic. So what it does, it's a printer that prints in plastic. Here's an example of something that was constructed. This is a little threaded fastener and a nut. And if you can see on there, there's another sign we've just printed. So we're just learning how to use this. We haven't gotten too experienced with it yet, but it's going to be great for making parts for robots and making all kinds of custom stuff. We also have a counterpart here. We have a 3D scanner. And this device, this is an output device. It prints in plastic. This is an input device. It scans an object in 3 dimensions. It rotates and it bounces a laser beam off the object. And it makes a digital model in your computer of that object. And then you can turn around and print that object on the printer. So it's possible to digitize an object, alter it somehow in the computer, and then print out a replica of it.
At Valencia College, we offer a wide variety of mobile application courses. This is iOS programming for the iPhone and iPad and iPod. And we have these labs here at Valencia College with Mac computers, so the students can develop their own applications for the iPhone or iPad. This is the development environment we use, which is called Xcode. And you could put objects on the screen and program them to run in a simulated environment just like the iPhone right here. We have up-to-date software giving the student the best experience in iPhone application development. As you can see, the simulator right here works just like an iPhone, and we're able to use it just like you would use a regular phone. The Xcode environment allows you to drag and drop items on the screen to make a design, and also to write and develop code to make those designs come to life. Here on West Campus of Valencia College, we have a dedicated Mac lab for our mobile application programming. And you can see here that every desk has a Mac on it, and they have headsets and the software needed to do mobile development. We spend a lot of time and effort to creating this lab so that the students will have the full experience of mobile application development. We also, in addition to having the Mac labs, we also have tablets for the students to use for mobile application development. For example, here's our cart full of iOS, Apple, iPads. And right here, the student could plug into the iPad, connect it to their Macs, and develop applications so they could test it and use it on a real device. This is important for developers to learn on a real device because that's how it's going to be applied in the real world. We also have a cart that's a class set for Android tablets. And these, just like iOS, we have a tablet that can test on a real device so a student get the full experience. We walk through the steps of a student being able to become a developer by signing up to either Apple or the Google development area. And they could choose whether or not to go ahead and become an actual developer through the course that we provide. We also have a cart for our new developing Windows mobile class as well, coming soon.